Good evening, all. Last videos we have discussed statistical model, how it is being taken care of the losses of time, frequency, and spatial losses. Okay, and there we have seen few models which is being taken care. It is being discussed for statistical models. Relay models, these were the main models, and there we have used how do we are coming over the problems of the losses by using dollar effect or multipath time and frequency. Okay, now we are going to discuss empirical models, which is more important to discuss, which is more complicated, but same time it is more accurate models we'll be using here. Statistical channels models not consider specific wireless propagation environment. Means environment surroundings, okay, of the earth terrain, etc. They are not. Empirical semi-imperial wireless channels models are specific models which have been developed to accurately estimate path loss, shadowing, small scale fast fading. Empirical models also based upon extensive measurement of various propagation environment. They specify the parameter and method of modeling the typical propagation scenarios in different wireless systems. These models take into account realistic factors as okay, angle of departure, angle of arrival, antenna array factions, angle spread, and antenna array gain pattern and other real-time factors. So this is more accurate modules we'll be using, which is getting the fading channels losses to be sorted out by these models, empirical models. Different empirical channels models exist to different wireless scan. The wireless, if you say something, wireless is taking mainly in suburban, I told, suburban macro, and urban micro cells, and so on. The channels experience the different wireless standard empirical channels models are also different. Empirical models are, if we, that is the reason LT channels models are for path loss. The models used in modeling the outdoor macro and micro cells wireless environment. If we say to improve the efficiency of the system coverage areas of the service provider, definitely where in the city areas, the metropolitan city areas, where the cells are divided into micro cells to increase the channel's capacity. And that is referred as 3GPP channel models. First, we need to specify the environment where an imperial channels model is used. Suburban macro, urban macro, and urban micro environment. Base station to base station distance typically larger than 3 km for a macro cell environment and less than 1 km for urban micro cell environment. Okay, so because in 1 km the many number of people are there, so that is generally we are keeping the distance of between the base station of transmitter and base station of the receiver 1 km only, urban microcell environment. For 3GP microcell environment, the path loss is given by so-called Cos-Theta model, which is very famous to come over the environment losses due to environment, which is given by the following easily computable formula. You can see P loss of the Cos-Theta model, which is given losses in dB equal to 44.9 minus 6.55 log 10 HB log 10 D plus 46.3 plus 33.9 log 10 FC minus 13 minus 82 log 10 HB and minus A HM plus CO, that constant. HB base station antenna height in meter, FC is carrier frequency in megahertz, we always say. D is the distance between transmitting and in the kilometer antennas, okay, these two transmitting end and receiving end. A relatively negligible correction functions we are correcting. See, always we are doing some of some of study, based on some study of the data, we say if we are doing this, we have to add little bit more or little bit less. That the study of the things, various studies of that, we find that we have to Hatha has find that with relative language correction function of the mobile height defined, that is given by this much. Okay, that is nothing but the 1.1 log 10 fc minus 7 hm minus 1.56 log 10 fc minus 0.8, where hm is mobile antenna height in meter. So this is the cost model which is being given a final, okay, final equations of the there is corrected little bit and they added some values there. So this part, you can conclusion is nothing but LTE system also operate with below sometimes 1500 megahertz, for example 700 megahertz, and then the frequency losses are very less. But high frequency from 1500 to 2000 LTE we are using, then frequency losses are more. So the empirical model also can be used in such scenarios in the Hatha model. This we have discussed, okay, for about 1500 to 2100 megahertz, where the frequency losses is more, how it is affecting in the environment function. That, but here in this also taking place for where the, okay, frequency we are using for transmitting to receiving and less than 700 megahertz. Okay, what to be done here? That to be see that which closely related cos theta model, but with slightly different parameter here is included. Several slightly different Hatha model exists. Okay, it is in empirical model, but depending on the weather environment, which urban, suburban, for open area, Hatha model for urban area defined by here. These calculations, okay, you can remember and keep it, and that you write it. Here we have imperial models for multipath LTE channel. We are using the received signal of the mobile receiver consider and time delayed version of the transmitted signals. That use that are multipath channels in nothing but and time delayed version that getting delayed to each other angular functions, and it is that is reaching with the with the angular form at the receiver end. And this figure you can understand we are having, okay, one end to MS mobile subscriber direction mobile subscriber here, and that is we are having cluster subpath we are giving where the main path is this one, and how exactly is related. You say MS array broadside and it will be a base array broadside, and how the theta and all those things subpath cluster and basic antenna array, all those things we are, this is antenna array, this is MS array. So we are discussing now, earlier we are discussed from antenna to antennas, okay, other models, but this model is basically environmental model where the base station subscriber only wireless cellular based, okay, to be accounted. This model is providing where it's taking by wireless system. So end path or the characterize the power and delay and choose according to prescribed channel generation procedure as follow. So many multipath of the scattered or from environmental from one base station which is occurring before it is reaching the delay angular effect, it will be there with the mobile subscriber. Mobile will be using the best strength, and okay, that way will be occupying and will be using, there will be using other factors such as losses of time and frequency also included with the, okay, Doppler consideration. The number of paths and ranges from 1 to 20 depend on the specific channel models. For example, 3GPP model has n equal to 6 multipath component. The power distribution normally follows the exponential profile. Each multipath component further corresponds to cluster of n subpath. Definitely, which each subpath characterize the incoming signal from the scatter. I told multipath taking place either due to scatter or reflector. Okay, the m subpath have random phases and some path gains specified by the given cursor in the different stand. For 3 GPP, phases are random variables uniformly distributed from 0 to 360 degree and subpath gains are given by 3 GPP channel model. And this is n multipath component from the nth transmitter antenna to the S receive antenna. So MS also getting scattered signals from the base station. In between this will be having scatter or reflected, and that way it is taking multipath. Empirical models is defined here. You can say these are the formulas which we are giving here. These are the terms. You can go through all those things if you remember. Okay, all those things. This is the end of the, generally we have 3 GPP model. One more model we are having LT semi-imperial channel model. Okay. Considering a fully empirical channel model is relatively time consuming and computationally intensive due to a huge number of parameters involved. Therefore, semi-imperial channel models have provided the accurate inclusion of practical parameters in real wireless system while maintaining the simplicity of the statistical channel model. Well-known examples of simpler multipath channel models include 3GPP that become 3GPP2. The people are moving, mobile subscriber, talking, moving on the pedestrian. So we have two models here, A and B, and vehicular, moving the vehicular A and vehicular B. There are these four models which show a low mobile pedestrian. The mobile is moving not that fast, they are working. They are on the cycle or the car or maybe pedestrian. So where we have to use low mobile pedestrian mobile users or high mobility using vehicle. So power delay profile channel determines the number of multipath taps and the power and delay each multipath component. So this one we are having all together, we can understand, we can see their empirical model where we are having each multipath component modeled by relay fading with a different power level and the correct correlation with the time domain created accordingly Doppler spectrum corresponding specified speed. So pedestrian mobile subscriber model which is using pedestrian A model or flat fading models corresponding to single relay fading component a speed of 3 km per hour maximum. Whereas in B model corresponding power delay profile 4 path of delay 0, 11, 19 and 0.41 microsecond, 0, 0.11, 0.19, 0.41 microsecond and power profile given by that much at the 3 km hour. Where vehicular A model, mobile speed is specified 30 km per hour, assuming for multipath component exists, and this is the given microsecond and power profile is that much. For vehicular B models, that are also 30 km with 6 multipath components. So these are the models people keep trying new solutions to come over the how to be rectify the problems, losses, etc. They have done it, many things, and finally A and B combined, vehicular A and B combined, that is referred as these models. That is the end of empirical models used in to solve the losses of the wave propagation in the time, frequency and environmental. Okay, that's all. Thank you very much.